All right, good afternoon. I'm Russ Leftwich. Welcome to the FHIR workshop, and we are excited to have you here. Let me start out by running through the agenda and what we expect you to be able to get out of this workshop. The main point is to get a conceptual understanding of FHIR, why we needed FHIR, and then take a dive into the FHIR specification itself, which is open source, free on the internet, just to understand what's there. And we'll take a hands-on look under the hood at FHIR with a web app that will give you directions to, and there is a script, but that doesn't come until after the break at midway. And then we're going to take a few minutes to take a view of the future of FHIR, where FHIR is going and how it's evolving. The benefits are that you should get a conceptual understanding of FHIR and how it's different from the existing standards that came before it. We're going to give you some concept of detailed clinical models and of semantic interoperability and the relationship between the two as concepts. And we hope that you will be able to start imagining a world with FHIR. You will not go out of here able to develop a FHIR app. I think many of you will go out of here able to imagine what a FHIR app in your healthcare work environment might do for you and what the data it would need would look like. So those are the objectives. So I'm Russ Leftwich. I'm a senior clinical advisor for interoperability for InterSystems. I had a past life as a practicing internist in Nashville, Tennessee. I retired to start a second career in informatics, and I was a CMIO for the state of Tennessee for 5 years, and then almost 7 years ago joined InterSystems. Laura Heerman will introduce herself later. She's a Chief Clinical Information Officer for Graphite Health, a newly formed organization that she will explain briefly in her introduction. This is the 18th time Laura and I have done this workshop, and the ambitious title that was in some of the agendas, that this is the best explanation of FHIR they've ever heard. Somebody has always said that to us after our previous workshops. We intend to recreate that comment. So I want to start out by talking about Health Level 7 International, which is an ANSI accredited standards development organization, and that's where FHIR comes from. HL7 is a volunteer organization, has hundreds of volunteer members worldwide who work on the creation of standards. There are over 40 work groups in HL7 with various mostly domain-specific purposes, and they create projects to develop standards. There are, in addition to 3 5-day-long working meetings each year, one of which is usually outside the U.S., there are over 100 conference calls a week that these work groups conduct. All of the HL7 standards are open source, freely available and accessible on the HL7 website. InterSystems, I'm proud to say, has been a benefactor member of HL7 for over 20 years, along with a number of other organizations like InterSystems. First, I want to talk a little, before we get started, about how FHIR is different. FHIR is the technology of the World Wide Web. It is also different in the way HL7 develops the FHIR standard. It's a agile software type development process, which is unlike the way standards in the past have been developed. All of the published versions of FHIR are available for download on the web or access to read the specification. They all have human readable components as well as a machine readable model of the standard that's there that you can download and implement. Previous standards have been published as documents, as PDF documents, and somebody had to read them, interpret them, and implement them. That's one big way that FHIR is different. It has this machine readable content that's downloadable from the HL7 website. In addition to the published versions of FHIR, there is also on that website what's called the current build, which is literally the next candidate version of FHIR, also downloadable and implementable in a machine readable format. But almost every day in HL7, in response to a work group's voting to change something in the FHIR specification, changes get made in that current build. So it is constantly evolving. At some point, the current build that's there now will be published as FHIR Release 5, but this is part of the development process, that there are literally day-to-day changes. Only about a dozen individuals have the authorization to make changes in that current build specification, but that's a significant difference in FHIR. The other thing about the FHIR specification is when you go on the website, on every page you can enter a comment about the specification, not about the published versions because they don't get changed, but about this current build. You can literally enter a comment, a change request. It will be looked at by the relevant work group in HL7, and changes are often made when the comments seem to be relevant and accepted by the majority. The other thing to know about FHIR is that the same people who brought you HL7 version 2 and CDA and over 300 other published standards and implementation guides from HL7 are the same people who are building FHIR. So there are a lot of lessons learned going into FHIR, learned from developing previous standards or existing standards that came before, and learning what worked and what didn't work, and putting those into the FHIR specification. So how did Laura and I get to doing what we're doing today? Early in the course of FHIR, would we consider creating a process to validate the FHIR resources, the basic building blocks of FHIR, to validate those from a clinical standpoint? We had already been making comments about some things that didn't make sense clinically in the FHIR specification that was evolving. And I can tell you there is no substitute for having actually practiced and been involved in patient care and taking care of patients to inform what should be in a healthcare data interoperability standard. So we readily agreed to do that, and a GP turned software developer in New Zealand named David Hay, who was one of the high priests of FHIR and still is, he developed this web app that we're going to use later today that's called ClinFHIR, and it's at clinfhir.com. It's openly available. And he developed this web app and has continued to evolve it. It's sort of a labor of love for him. A lot of people showed up who weren't clinicians and weren't there to help us. They were there to learn about FHIR. So we got the idea that there was a need for people out there to get insights into the FHIR specification and we started doing these workshops as a outside of HL7 event that we could help people to learn about FHIR. So that's how we got to this point today. And as I said, this is literally the 18th time we have done this workshop. So why did we need FHIR? Well, I'm going to sum it up with a short few things to tell you, and then Laura's going to go a little deeper into this later. But in 2001, the Institute of Medicine, which is now called the National Academy of Medicine, published a book called Crossing the Quality Chasm. And one of the startling things that they concluded in that book was that there are over 100,000 deaths a year in the United States due to medical errors. A lot of people didn't believe that, pushed back on it, but in the years since then, it's become apparent that that was probably was a significant underestimate. And why that happened, the other points made in this book were that the medical care, clinical care in the United States varies. And in some places, some institutions, it's obviously a lot better and they have better outcomes than others. But without data interoperability, you can't really do an analysis of why the outcomes in one place are better than the others. You can't hope to improve the outcomes in the places that aren't doing as well, and you really can't take care of patients on a day-to-day basis if you don't have data interoperability that is beyond what we had in 2001, and although we've made progress, it's still beyond where we are right now that we need to get to. So before I conclude the intro part, I want to say a bit about InterSystems and our FHIR technology. InterSystems made a commitment over 5 years ago to be on the leading edge of FHIR, and so far we're there. We have one FHIR stack in all of our products and technology, and that is a significant advantage. It's not recreated for different products. Like all of our technology, our FHIR capability is scalable both vertically and horizontally, and it is intended, it will be part of living in a hybrid interoperability. I made that phrase up, but it's the idea that the world of the future, as far as we can see, is going to be a mixture of data streams that are in different standards. HL7 version 2 is in 80% of the systems in the world. It's not going away anytime in the foreseeable future. You couldn't make an economic argument for replacing all of those systems, even if you had something better. It's just not going to happen. And the truth is, for the most part, those systems do what they need to do relatively well. So in our meeting this week, there are a number of opportunities to learn about InterSystems FHIR technology. There's some sneak peeks about what's about to come out in our FHIR technology, so I hope you will catch FHIR as the week goes by and look up some of these sessions on the agenda, the app. This is our schedule that we had starting out, and we're going to stick to it with about 15 minutes delay as much as possible. So with that, the next part of the presentation is the concept of FHIR. So conceptually, without being any more technical than you need to be to use the internet every day, I'm going to explain FHIR to you. And I'm going to start by going back to the 1980s. And the 1980s was when healthcare data interoperability really started. That's when the HL7 organization started. And the reason it started was not that we wanted to exchange data with other organizations. The reason healthcare data interoperability started was because hospitals started to have more than one system, and they had to connect their systems. There was a registration system, the pharmacy had a system, radiology had a system, and they had to connect those systems to each other. And somebody observed a few years ago that the average hospital in the US has over 80 IT systems within its walls. And there's still a need to connect those systems. We still do that. InterSystems does that as well as anybody does. But we have leveraged those data standards that were created to connect two systems together to connect over 80 systems together, and that doesn't count the acquisition of hospitals by hospital companies, and you have N times 80 systems that you may need to connect. So that's been a great challenge, but that was part of the inspiration for FHIR. So not only is there data in more systems in the hospital, but there's data in a lot more places than there was in the 1980s, and it continues to grow. And we all know this. There's data in pharmacies, insurance payers have data, people have data on their mobile devices, they have data in home devices, they have data in genomic sequencing labs, data in outpatient facilities, and the number of places continues to grow. And now, interoperability doesn't mean connecting two systems together. Interoperability really means being able to be in one place and see all that data in all the places it is from that one place, the way we do in other business domains, the way we do on the internet every day. So interoperability is seeing all the data from all these sources in real time. That's today's meaning of interoperability. So not only is there data in more places, but there is a lot more data. And Dr. William Stead at Vanderbilt wrote a paper a few years ago where he estimated the amount of data that existed for complex decisions in healthcare. And his estimate was that in 1980, there were about 10 facts per decision, complex decision in healthcare. And in 2020, by that estimate and the exponential growth of data, which is an estimate but seems a very reasonable estimate, by that estimate, in 2020, there are 1,000 facts per complex decision in medicine. Not all decisions are complex, but I would argue that all of the decisions are getting more complex. So the limitation here is that the human mind can handle 5 decisions, or 5 facts, in making a decision. And that hasn't changed. I like to think I can do 8 or 9, but I was behind in 1980, and now, like everybody else, I'm hopelessly behind. So that is the challenge we face, and obviously the only solution to that is to have computers that can help us with those decisions, which involve 1,000 facts instead of the 5 that we're capable of handling. So it was that reality about 10 years ago that led the HL7 organization to form a task force, and they asked that task force, what if we created a new healthcare data standard from scratch? What would it look like? Because version 2 was almost 30 years old, CDA was 10 years old, HL7 version 3 had really failed to get adoption because it was so complex. You had to have a PhD in version 3 to even implement a simple use case. So it was clear that what existed was not sufficient for the future. So that task force actually the idea came from a gentleman in Australia who lives in the outback near Melbourne, Graham Grieve, who came forward with the concept that we now call FHIR, Fast Healthcare Interoperability Resources, to accommodate the fact that data was moving from offline to online, that there were data transparency efforts around the globe, and that data was becoming more and more a mixture of narratives and coded data. So that was where the concept of FHIR came from. So FHIR, to explain it simply, is a RESTful API, a representational transfer state, representational state transfer application programming interface. That is the essence of what FHIR is. What explanation that will help those understand this who are not familiar with the REST API concept is travel websites. So if you went to your favorite travel website and entered that you wanted to go from Boston to Seattle on June the 15th, in a few seconds you would see a list of flights from different airlines with departure and price and so forth. Well, that's not because your favorite travel website has downloaded all the airline schedules. That is because all the airlines have agreed on how to ask for the data in an airline flight and what you get back in return. That's a REST API in the travel industry. That is what FHIR is for healthcare. It's the same technology, and it's the agreement on the meaning of the data in healthcare. And that's where it starts to get hard, because as you can well recognize, the data in healthcare is infinitely more complex than a data in an airline flight. So I want to go from here and explain some of the basic concepts in the FHIR standard. And the first is resources. Resources are the basic building block of FHIR. They're the smallest thing that you can exchange in a FHIR data transfer. And that's resources as in URL. Remember, URL stands for Uniform Resource Locator. So these are the idea of resources in a web technology sense. Those resources have a defined, a known location, that is that URL-like address. They have a defined meaning. That's what the FHIR specification is, which lays out the healthcare data model for those resources. And the data resources in FHIR are logically discrete data concepts. They're not a data element. They're something larger than that, something like a patient. And to define a patient, you need a first name, last name, medical record number, gender, birth date, address, and so forth. Those are the elements that make up the resource that is the patient resource. There's a family history resource. There's a care plan resource, procedure resource, medication resource. There are some resources that are not data, but are infrastructure resources. So the list resource allows you to build a list of patients, a list of medications, a list of problems. And there are other resources that have to do with specifying the rules that you use in a FHIR implementation. We're not going to talk about those today. We're just going to stick to the concept of the data, the resources that can represent data. The second concept that I want to explain today is FHIR profiles. So FHIR profiles are all the resources, all the rules and relationships of the data in that profile for a particular use case. And so the profiles vary by what use case it is. They include value sets or terminology bindings for that profile, and they may include FHIR extensions, which we'll come back to in a couple of minutes to explain what a FHIR extension is. But most importantly, interoperability comes from shared profiles, from using the same FHIR profile between two systems or two or more systems. That's interoperability. Just using FHIR does not create interoperability. It's using the same profile. So what that means is once you've specified that profile for a particular use case and represented your data using that profile, you can move that data between different interoperability paradigms without changing it, without transforming it, which is unlike any other existing data standard in healthcare. So if you got, say, a lab result from a API, from a REST API, specified according to a FHIR profile, you could take that lab result, you could put it in a document, cut and paste like, or you could use that, take that lab result and put it in a message to another system like a HL7 V2 message, or because FHIR is inherently machine readable, you could use that that lab test in some decision support service, for example, and it is computable as it is because it is specified according to a FHIR profile. So that is maybe the most important thing you will hear today is that interoperability is using one profile to specify the data. So it's said that true interoperability is when we exchange information and we mean the same thing. But it's not really us that means the same thing. It's the computers that have to mean the same thing because we're pretty good at understanding when we mean almost the same thing as someone else or the same thing. So as an example, let me propose that there are two individuals who have not seen this animal before. And one of them says, it's a white horse with black stripes. The other one says, it's a black horse with white stripes. Well, they'd figure out pretty quickly they're talking about the same thing, they're talking about a zebra, but to computer systems, those are not the same thing. Those are two completely different things. And it might be true that we could program computer systems to recognize that those are the same thing, but in healthcare, there are literally hundreds of thousands of concepts that you could explain in two different reasonable but different ways, so we can't do that. We really have to decide which explanation of every healthcare data concept we're going to program into the computer to create interoperability. So what we call those descriptions is clinical information models, the description of a healthcare data concept for a particular use case. It's all the relationships between the data in that use case. It's the rules of how that data can be used, and it's the vocabulary or terminology bindings for the data for that use case. So that's starting to sound a lot like a FHIR profile, and in fact, that's what a FHIR profile is. It is an implementation of a clinical information model. So to give you an idea about information models or data models, we've had them, we've used them. A lot of us didn't really think about that's what we were using, but that's what a clinical document is that every domain of healthcare is familiar with in some form. So suppose we took a history and physical from an EHR system and printed it out, and then took a pair of scissors and cut it up into individual data elements, if you will. So there's all these pieces of paper that have a data element on them, and we pick up one and it says diabetes type 2. Well, we know what that is. That's not complex. But what we don't know is whether that's a condition that the patient has, or it's a condition that the patient had before they had weight loss surgery and lost 200 pounds, or it's a condition that their mother had and it was in the family history. So that's the importance of the relationship of data elements in a data model, in this case using a document, and that's what FHIR has to be able to reproduce somehow to create interoperability, those relationships between data elements. And that then forms a FHIR profile. So let me give you a 30,000-foot view of a FHIR profile for a procedure. And it might be a laboratory test, it might be a imaging procedure, it might be a surgical procedure. They're all procedures, and they all would have a similar profile. It would look almost the same from 30,000 feet where we are, but if you could zoom in on the FHIR resources in that profile, you would see there are a lot of details that are different, that are the specific profile for that specific procedure, whatever it happens to be. So for every procedure, there's a FHIR procedure resource that says what procedure exactly it is. There's a patient, a FHIR patient resource upon whom the procedure was performed. There's a FHIR practitioner resource who's the performer of that procedure. In most cases, there is an encounter in which that procedure was performed, and there's a condition that the patient has, the FHIR condition resource, that's the reason that procedure was performed. And for a lot of procedures, there's a diagnostic report that is produced from the procedure. So that is the 30,000-foot view of a profile for a procedure. Now, the other important thing that FHIR has brought that is a quantum leap from where we've been with data standards in the past is a terminology server. So it's a technical concept of having a server that contains all of the code sets and vocabulary sets that you might want to use in your FHIR profiles. And then there is in the FHIR specification a description of the operations that you can perform on those terminology value sets and code sets to create interoperability and to use a particular code system or value set in your FHIR profile, so that terminology is available on a server at a URL. That server might be a publicly shared server or a server for an organization that may have many different FHIR applications, but they can all access that same terminology server. So there is no downloading those value sets and terminology sets and updating them on your system. They're all accessible in one place, which might or might not be public, but there are public terminology servers out there now that are used for testing and development of FHIR profiles and applications. So that's a very important way that FHIR enables interoperability of the type we need for the future. So say you were developing a FHIR app that had to do with treating pneumonia, and you would want your value set of the antibiotics that can be used to treat pneumonia for your app. You would want them to all be in the same code system. You don't want one code system for one country or mixed with a code system from another country or another code set. So you want to specify exactly what codes can be used for that list of antibiotics that are going to be used in this app, and you could store that on a FHIR terminology server, and anybody using that app or anybody developing another similar app could use that same code system accessible as a URL. So that's a very powerful way that FHIR enables interoperability, because you really need those terminology bindings, those vocabulary bindings to create a clinical model of some particular use case. The other thing I said I was going to mention a little later is FHIR extensions. So there is a formal definition of what an extension is in the FHIR specification. And an extension is used to represent data elements that are not part of the FHIR standard itself. The reason this was done was to keep the FHIR standard as lean and manageable as possible by representing only the 80% of data that's represented in most systems. It's a rule of thumb. There's no really measurement of exactly 80%, but data that's in most systems, data elements, are represented in the FHIR standard itself. If you have a data element for your use case that you need in your use case, you're going to create a FHIR extensions. And FHIR extensions extend FHIR resources. So they add a data element to a FHIR resource. And let me give you a simple example that's not a clinical example exactly, but easy to understand. And a clinical example would be the same concept. So suppose you operate a clinic that does travel medicine, and you have patients coming from other countries to get care in your clinic. So you want to know what their nationality is. Well, nationality is not part of the FHIR patient resource. So you would create a nationality extension for the FHIR patient resource and use that for your travel medicine clinic to represent nationality. The other thing about extensions is there's a requirement in the FHIR specification that when you create an extension, you publish the definition of that extension to a publicly available URL, a resolvable URL. So anybody that you send data to that has that extension to it can actually discover what that extension is, what it means, and that is a very powerful way to enable widespread interoperability across many different systems. So extensions are the way you represent the 20% that's not in the specification. And that brings us to the last concept I want to talk about, which is sort of the end game of FHIR, and that is FHIR implementation guides. So a FHIR implementation guide is all of the FHIR profiles and extensions and vocabulary bindings that you need for a particular use case, whatever that might be. And in those FHIR implementation guides, in addition to that technical content, is a description of the intended use of this FHIR implementation guide and some examples of how it might be used, all bound up into an implementation guide. And then HL7 has a web publishing tool that allows you to publish those FHIR implementation guides as a package that's downloadable and machine readable, containing all those FHIR profiles and value sets and such. And then the fact that it's machine readable means you can validate your implementation, your application that you've developed, against that implementation guide to make sure it's compliant, conformant with your implementation guide and the profiles in it. So HL7 has a public website where those are published. It's registries.phir.org, and I don't know, there's almost 200 of those implementation guides published there. Most of those have been balloted in HL7, voted on. There are numerous other implementation guides that have been published independently by somebody who just went to the effort of creating an implementation guide and then making it available. But the ones in HL7 are voted upon and have some credibility from that standpoint. So, with that, I will turn it over to Laura to take you into the next presentation.
All right, let me tell you just a little bit about myself. I am Laura Hierman. I am a nurse that has been in informatics and working with FHIR again for probably 15, 20 years. And I just recently moved from Intermountain Healthcare to Graphite Health. Graphite Health is a new nonprofit that is being started by Intermountain Healthcare, Presbyterian in Albuquerque, Kaiser, and SSM in St. Louis. And it really is all about kind of the sharing of a lot of the data elements and sharing, coming to common ground for some of the things that we need to do to reach the true interoperability, which I will get into a lot of details, not about graphite, but about what we're talking about here today. And I'll kind of point out in one of my later, one of the last presentations, just kind of what graphite as an organization fits into. Those of us who are working in IT, we know that we have a lot of expectation out of these tools that we're working on. We expect that using IT in healthcare is going to help us enhance the quality and safety of our healthcare. We want to reduce the costs, and we think we can integrate the care across multiple providers and multiple sites. We think that we can help with that decision making and managing all the data and information that's coming into us by helping with decision support. And by doing all of this, we're going to make patients happier and the healthcare workers happier and decrease their burden of work. Isn't that kind of what we all think is going to happen? That's the prayer, right? That's the vision. That's where we are. The thing is that all of this depends on the interoperability between these healthcare organizations. And that is something that, the slides are not coming along, we're going to talk about. So where we're at today and the dangers of our limited interoperability, I have a little story for you. And this is one story of many out there. And in fact, I bet there are, if we were all having a cocktail reception or something, we would be saying, we all have our own stories like this. But this one I'm going to share with you today is about Eileen. And she is a colleague of ours who came to an HL7 meeting in 2012 in San Antonio. She came to that meeting from Singapore, which is where she lived. And she wasn't feeling very well on the plane. She finally ended up going to the local ER. So we're in downtown San Antonio near the Riverwalk, which I'm sure many of you have been near there. And there's a community hospital there. I don't know how many beds it is, but it's probably one of our usual community things, something between 150 and 250, 300 beds. And in the ER, she was seen and ended up getting admitted. She was presenting with a fever, nausea, vomiting. She had hypotension, a high lactic acid, and an abnormal white count. And she had only been in the States probably at that time about 2 or 3 days. And the ER docs were really concerned about the fact that she'd been on an international flight with a layover somewhere, I don't remember. And she came from Singapore, so was it something that they didn't know? She was a young woman in her 30s. She had been married about, I think, 3 or 4 months. She had run in a marathon 2 weeks before. And so they weren't sure what she had been exposed to and what she had. But what ended up happening is that she died from septic shock from untreated group A strep. And that was a tragedy, because had they been able to gather all the data about her, have decision support available to them, and help them recognize the constellation, they probably would have recognized what she had and been able to treat her with penicillin. And this is what's happening in our healthcare today, is that we have many of these things. And Russ mentioned, that when they wrote the quality of Crossing the Quality Chasm book in 2000, the number of deaths that they thought were happening in the U.S. today. And this is an article, and it's already getting dated because it was done in 2016, but it is looking at different research studies and extrapolating. If you put these together and look at what's happening in our healthcare system today and how many patients we're losing due to medical errors and issues of mismanaging the information that are at the fingertips of the clinicians, we're well over 250,000 deaths a year. This is inexcusable. We know how to take care of patients better, and we are just not doing it. And part of the problem is the tools that we have at our fingertips are not helping us. And so what are we going to do about that? So we talked about this, that our brains And we have the best clinicians out there, and they're doing the best they can. And boy, did they get hit during COVID and are still recovering from that. And we hope they do and stay in the job. But a lot of them are totally burned out and trying to leave because it's hard work trying to manage all of this for all of the different people. And so we look at this and say, well, from the IT perspective, how can we help? We can help by putting in decision support modules. And on this screen is some examples of all the different decision support modules that are possible out there. And I'm sure that many of you work with these as well, either developing them or implementing them, supporting them, all the different roles that we have around decision support. And at Intermountain Healthcare, I know that they had, when I made this slide, and it was a couple of years ago, approximately 150 decision support rules module sets, decisions that were being supported by a decision support module. Some were simple, some were complex. But we know that even though that sounds like a large number, it's just very few, and it was the easy ones. And they had a backlog of over 5,000 different needs that they would like to have. But there's no way, in the current way that these things are developed, to get from the 150 that they have to the 5,000 that we need. And so we're looking at that we really need to figure out as all of us involved in IT. It's not an Intermountain Healthcare problem. It's kind of everything in the big picture and the interoperability. How do we fundamentally change how we provide healthcare with the IT tools we have? So now let's go off in dreamland a little bit and imagine some things. And I want you to think about that phone that's in your pocket, your purse, laying on the table next to you somewhere, and how easy it is for you to go to a marketplace and pick the best weather app, the best traffic app, even your diabetic control. You can go out there and choose an application that will help you do multiple different tasks in life. And you can choose the best of the breed or the one that works your workflow, or you just like the colors used on the screen design. There's all these reasons why you can choose it. We don't have anything like that today in healthcare, except within the niche systems of Epic or Cerner or InterSystems or others. You have your own place, and we can't share. So from like the healthcare perspective, Intermountain Healthcare has done 150 apps. Mayo has done an equal number or more. Kaiser's done more. Name your healthcare system, they all have them. How many of them are they repeating what everybody else is doing? We're not able to share the knowledge. It's not even sharing the patient data. So I, as a patient, go from one clinician to another clinician in two different systems, maybe one in Utah, where I'm based. We have the University of Utah and we have Intermountain Healthcare. And patients go back and forth between them, and let's throw in the VA. Several patients go there as well. My data is kind of stuck in all those three different spots. So we talk about moving the patient data. What about the knowledge? So why should the University of Utah and the Intermountain Healthcare both be creating the same decision support systems and testing them and maintaining them for each one? I mean, they both have to do ventilator management, diabetic management, bilirubin, all of these things. So why are we not trying to figure out a way to share this? So not just the patient data, but the knowledge. Today, you're well aware of the left side, the numerous one-on-one connections, and that is often based on the HL7 FHIR. We're doing interfaces with lab systems, et cetera, and we're doing one-to-one, things like that. But imagine a very seamless plug-and-play interoperability ecosystem where we have a common platform and we can very easily put all the different things we need to kind of plug in and get the data and the knowledge. So we step back and think about this and say, what is it going to take to make that happen? And this is maybe not a comprehensive list, but it's one that we refer to a lot. It's not all just about the technology. There's a lot of things that have to happen here from the clinicians themselves. They need to figure out what it is they want, help us prioritize it, and then they're the ones that are carriers of the knowledge. And guess what? I'm sure a lot of you have experienced this before. You take 3 physicians in the same room, and do they all practice the same way? Not always. There's subtle little things in how they might approach their diabetic patients. And you know what? They're taught that. When they go to medical school, Dr. Leftwich, he's a doctor, he's going to call me and get his shepherd's hook out. No, but that's part of what, you choose a medical school to go to, and it's the art that they teach you. There are a lot of things that happen from their professors that are teaching physicians and even nurses. It's not just always the facts out of the clinical, it's the art and how they apply some of the facts. And that's okay, but sometimes it's not always the best way that we can treat many patients across many areas. So we've got to get the clinicians to understand they have to guide the content, but not only guide it, they often have to get to a point where they'll agree on things, because otherwise they have the IT people running in circles. I mean, we've got 3 doctors in one hospital, perhaps, that have us all, it takes us 6 months to do something because they can't even figure out how we're going to define a heart rate. I mean, that's ridiculous. So they have an ownership in this, and they need to step up. Technical, come back to the policy and legal framework. I mean, you're well aware of things that are happening with the ONC, et cetera, and we're going to review some of those at the end of the day. And then the financial incentives. There's a lot of things the way that our healthcare is getting paid for today that doesn't always incentivize some of the things that we're saying need to happen to take better care of our patients. But what we're really going to talk about today is the technical advances, and even that, we're really kind of stuck on the data and the services. We're not going to talk a lot about knowledge representation or the API adoption. It's a little bit on implementation, but that's where we're at. So now, I just put the stuff in here again in case you're not on the WebEx, but we're going to dig into FHIR a little bit more. So when we talk about FHIR, FHIR is really all about sharing data, sharing content. It's not always about the storage. It's really looking at how best to get so that we have native data stores. How do we get so that we can move it and share it across sites and systems more easily? So the resource objects are representing named healthcare concepts that are very common in our EHRs. The resources represent self-contained computable healthcare knowledge artifacts. And the resources are designed to be findable, usable, extensible. So as Russ said, they're really built for this tightly contained minimal number as we can that will be most representative of everything. And when we say most representative, the target all along was to represent 80% of healthcare, and that 20% is where we profile, extend, constrain, things like that. And it was created to promote the access and the transfer. It's not meant for storage alone. People get that confused. And the other thing I forgot to acknowledge, Dr. Jim McClay, I give him credit for a lot of these slides. He often presents with us, but is not here today, so I'm borrowing them. Anyways, these are just some examples of where the resources are. We have clinical ones, we have very basic ones, there's some around administrative data, and then the process. Don't forget about that FHIR resources are not all about just the clinical data. There's also ways that we work with and manage and move the data. So again, we've already mentioned FHIR stands for Fast Healthcare Interoperability Resources. Once it got mature enough, which some of us who work with it say, was it really mature enough for this? But it was written into the Cures Act. It's freely available. It's detailed online, hyperlinked. You can get into that specification, and we're going to do that today. And it's full of different kinds of toolings and servers and libraries. It's very consistent, as we said. It's based on JSON and XML, which is well-known technologies that we have lots of people in the world that know how to use those tools. So it's not something unique and on its own just unique to healthcare. It was really designed with the implementers in mind, which is probably why it drives clinicians crazy, because sometimes clinicians are like, well, you can't possibly be saying that about healthcare, but we're coming around and understanding how to work with it. Remember that first line about clinicians? I'm one of them. All right, so the FHIR resource models, they're informed by and related to the healthcare standards, like all the other ones that we mentioned, and it is definitely based on what we've learned through V2 and V3 specifically. V3 got very complicated, so we'd step back and make it easier. It has the ontology that encapsulates the EHR functions. I guess this one, I kind of have the same thing in there, so we can skip that. Okay, so on this one, I'm going to go into the specification itself. And to do that, if you want to, you can go yourself. You can go to the FHIR specification. There's an orientation that's at hl7.org/FHIR. But the one that I really like to go to is just right here. If you do build.phir.org, and build.phir.org, that is the specification. And it's very scrollable, and it's very clickable. And so you can just kind of come in here, and the things to note are pay attention to what release is here. I'm currently on release 5, which is the draft. So this is probably some of the next one that's coming out. But if I clicked on a button at the top that talked about see all versions, you can see all the history and all the past of everything that's happened in FHIR. And boy, could I make that just a little bigger, even for those of you on WebEx. So as you can see, the current, this is the one where all changes are happening right now. So when we talk about any change requests or things coming in there, JIRA tickets, we're using JIRA to manage that. They're being changed there. The last one that was really publicly released is version 4. And then there's, so there's pound 4B. This is the one that's probably published. I always, because of what the work I do, click on current and go. But if you have to go back and see anything for some reason, they're all here. So then back here, the things that, I want to just say is that you've got, let me go back into my current build. Just pay attention to the levels. So this is where you can see there's level 1, 2, 3, 4, 5, and everything from very foundational. And you can see this is where it's your very base kind of data types, extensions. And this is not just all the extensions. This is kind of some of the workhorse around extensions here. And then you've got things about supporting implementers, and you can see if I can get it even bigger so you can read it. So you can see what kinds of things. Each one of these, if I click on them, goes into another whole page, and you get everything about it is here online and available to be read. And when you scroll down, you start getting into actual what the tree structure looks like. And then each of these are tabs that you can see everything from the JSON, the XML, UML, etc. So let me just go back to this. So in there, you're going to be able to find the release numbers, any kind of documentations, what's happening with the APIs, and any terminologies that are associated with those builds. So again, these are very small, logically discrete units of exchange. They have a very defined behavior. And with the way they're written, you can find them because they have a known identity based on their URL. It's a very complete transaction when you use them, and they're extensible. I think we've already talked enough about that they're based on the RESTful type thing. So the hierarchy of resource types. I mentioned the different levels when I was in the spec just a minute ago. And there's things of concern, especially kind of for the clinical content, as the administrative pieces, is also the medical records. Then we use the workflow to kind of build them and how they relate to each other. There's financial content and some reasoning in there. And the thing that was indicated in Russ's presentation also was the how they relate to each other. So there's always a lot of connectivity between them. And when we get into our hands-on experience in a little bit, we'll be able to really see how they're connected. So the thing to talk about here is the maturity level. So all of these, I'll come back to this just a minute. And if I go to the resources, and my favorite way is to come to alphabetical. But you can see in here, there's a long list of them, and I think we're at about 120-ish of different resources. And this is the list of base resources. So you're going to see in things like Encounter, but the two that I can really pull out is like observation. If you're going to do something, anything like a set of vital signs, heart rates, they're all considered observations. If you're going to do things that are called diagnoses or findings, that's often in wherever condition is. So this is the level of where these resources are. And if I want to actually say I want to create a profile around heart rate, I start with a base resource and then profile it into heart rate, and we're going to get into that. But the thing to note about the resources is that we have this limited set, is also these numbers behind it. And these numbers behind it is talking about how mature it is. Because some of these things have been around for a long time, and the ones that have been around a long time have been tested the most, and people are the most comfortable with having an N by it. Because in the world of balloting and things at HL7, if it hits normative, which is N, that's kind of the highest level of maturity. It doesn't mean that it can't change. It means it's really hard to change it because it's got a lot of use behind it, a lot of implementation, and so it needs to be, we don't take changing it lightly at all. But if you've got a 0 going, it's a new thing. It's the lower the number, the less mature it is. And there's several things in here. And what that means is that people have said, hey, I see a need for this. We need a resource for it. You've probably had to go through several meetings with, what did you call them, the fire gods?
The high priest.
The high priest.
Of fire.
With the high priest, because to get something added to this list is not easy to do. But you've fought it well enough to say we really do need to have something out here. It's not covering these use cases. It's not covering these needs. I can't use what is on the list already and profile it into what I'm trying to do here with this use case. So you get it on here, but then that means you need to start looking at how many other people can use it. How many other times can we use it on use cases and test it and things. And so as it goes through the maturity, which is here, 0 is draft, proposed, approved, and tested is 1, tested between 3 systems gets you a 2, balloted gets a 3, published in the trial use, which is STU, or multiple prototypes gets you a 4, and 2 release cycles, 5 plus production systems, you're at 5, and you have to go through all of these before you can get to normative. So there's a time that's in fact imposed as well to get to normative. So that's kind of what the maturity is about. This is just looking at all the different clinical ones and that we've kind of looked at before. And then again, here's a link to get to the patient resource. So to look at the patient resource real quick, I'm going to go ahead and do it at the slide level right now. But if we go into the resource and click and find patient, we scroll down until you see the tree level view. That's what this is a screen print of, is the tree view of patient. And you can see all the different things that are here that are describing the patient. So it has identifiers.
Can you zoom?
What?
Zoom.
This one I can't because it's a slide. I will in just a minute. We'll do the high level stuff. So you've got columns, the names, the flags, cardinality types, descriptions. And so then let me go back and find patient. And I really want it to be here. So if I click on patient, and I can come into it down here. We were down at this level. That seems to be as far as it'll zoom in for me right now. So what we're saying is that you've got the tree structure is this first one, and you can see what the name of the item is, and then the tree comes down and tells you all the things that are related to it. And you can see if they're alive or not, their address, marital status, if there's a photo attached, what's their contact information, how best do they like to be communicated with, what language, and kind of who's their primary caregiver, and some other link type stuff. And in here also, not only have the name of the item, it's going to tell you, these flags are like just message things. So this is telling us a normative, and then these are also some, it tells me that's in summaries. And if you click on flags, it'll tell you what the flags are. There's a little hint card there. The cardinality, for those of you familiar with databases, this tells you whether or not it's required or not. Very few things are required in FHIR, very few, but there are some. But you can look and find their cardinality. The data types, and I'm going to get to data types in just a minute. It tells you what that is. And then a description and some of the constraints, meaning that if it's been constrained to different value sets and things, many things are clickable here as well. And so I'm not going to click on all of these right now because we'll be getting into that. So the other thing that we do with these resources is we kind of like the relationships. And I hesitate in using words like group and bundle and things because those all have meaning. A group is different than a bundle and a list. But the list is something that's very important to us because that's how you make things. You make multiple items of one type of thing, either an observation or a medication or something. And then if I need a medication list, I take all those multiple items and I put them in the list resource. And the list resource will tell us that's the medication list and here's your list of medications. And you can do that with medications and problems and allergies, all sorts of things. And we're going to do that on the hands-on as well. So we'll be able to show that to you a little bit as we get there. Questionnaires is another way that we can kind of group some of these resources together. It's a very specialized resource that's important in what we do because this is where a lot of those surveys or screening tools that we do in healthcare is how you manage that. Because if you use the questionnaire resource, you can create all of the questions that you need and get them grouped so that you can actually say, this is the social determinants of health questionnaire we need to do. This is the smoking questionnaire we need to do, and kind of group them together. And the thing that's important, and these are examples over here, you can do past medical history, family diseases, research type questionnaires, quality, that type of thing. But to get the answers to that, it's in the questionnaire response. So again, very generalized resource questionnaire, generalized response, questionnaire response. You go in there and profile it, and you can make it do what you want to for what the specific use case is. And this is just an example to help you see when you've got a textual record of a consult. So what it says here is I have a first consult on a 12-year-old boy who came in complaining of pain in the right ear for 3 days, an elevated temperature. On examination, the temperature was 38 degrees Celsius, had an inflamed right eardrum with no perforation. The diagnosis was otitis media, and he was prescribed amoxicillin 250 milligrams 3 times per day for 7 days. Now, if you look over at the key here, We use the patient resource to say it's a 12-year-old boy. We use the condition resource to talk about the pain and the otitis media. We use the observation resource to talk about the elevated temperature, that is 38 degrees, and the inflamed right eardrum. When he comes back, we find he has developed a rash, and that's a new observation. So we now have an allergy, which is penicillin, and he's changed to erythromycin. So that's how the resources kind of fit together in the real world. So let's talk a little bit about structured and coded data in FHIR. So FHIR is really about syntactic interoperability. It's a very easily understood and implemented structure, but like we say, it's more exchange, not storage. But it does allow for you to put some coded data in there that is supported by the standardized terminologies. So the basic data types that are in FHIR are kind of listed here. And again, in the specification, if you just go to that data types, or you can click on the data types, you can learn a lot more about them. But we have simple and general. There's some metadata type stuff. There's identifiers, and then there's the value sets and where you can get bound to the terminologies. These are some examples of what the primitive data types are, and these are things that if you can't read it, it's saying things like date and time, and strings and integers, decimals, Boolean, some things like that. The complex, and this is small, I can't make it big, but the complex things that are here says like quantity and range, the human name, address, coding, contact point, timing, some things like that. So when you're in the structured data, you can kind of organize it in a way according to the schema of whatever you're trying to structure it to. But that limits it to things that are just kind of in grouping and in buckets. So you can think about, you have a collection of recipes, and you're storing them either by their ingredients or by how you mix it or how long you cook it. Whereas if you get into coded data, then you're really talking very specific. And so you're talking about, that this is the chicken type recipes, and maybe it's the baked chicken recipes, or things that are very much more specific. And so when we do that, you definitely have different things that you have to consider with your UI, but it can increase a lot of possibilities of what you do. And it also really increases our secondary uses of the data because of the decision support and the analytics that can be done with the coded data. So this is just a screen print, an example saying that in one resource, a condition is what's this little word at the top. I've got coded stuff happening, and I've got structured because I just have strings in here. And so even in any given resource, you can get into the specifics of that. So now the thing to know about the code systems that's also important to know is that codes are not just the code and the number. It's about the definition or description that goes with it. Because that's the one thing that we see is that you might find a code and it has a word with it, but if you don't read that description really carefully, you might be miscoding things, because you've got to pay attention to what is being said about this term description. You can't just assume that the name is what you think it is. So the standardized terminologies are really helpful in FHIR getting towards the consistent semantics. Value sets are really important. But the thing about value sets is that there are lots of them out there, and they're somewhat bound to what terminology system that you're using. And so you need to know in your, which like in LOINC code, I'm using LOINC, so here's the code. I need to know that code goes to LOINC because that, this is color of skin is what this is showing. It has one set of values, but if I go into another one, it might have a different set, and then my click just brought it up to show this is how an implementation guide is showing that I've got the LOINC, no, this one's actually saying SNOMED codes are what I'm using for my display. So I couldn't use the same and just assume that it's the same as what's in LOINC because the value sets are often different. We can't make assumptions on that. So let's talk just a little bit about profiling. So profiling, like we've talked to, you have this very basic general name kind of a resource, but we want to make it suitable for a use case. And so when we get into the profiling, it's really about taking this basic little piece of clay, and I'm either going to extend it and add more pieces on it to make it more specific to my use case, or I'm going to constrain it because, like I said, there's nothing that's really required or things in the cardinalities. You can constrain it by saying, I don't want you to include these things. And so by extending and constraining is how you profile. Let's see. So typical things that happen when you profile is that you say what things about that element are used or not used. You can say things about what API features are going to be used. You can talk about the terminology. So are you going to bind this to SNOMED? Are you going to bind it to LOINC? Maybe a combination, and you have to say how that combination is. You can talk about which particular data elements you might want. You can go ahead, let's say I bind it to that LOINC value set, but I only want 3 out of the 5 data elements. You can say that in your profile. You can say that when you're creating the profile, which then becomes part of an implementation guide. So this is an example. So you've got here, they've decided that you can limit, well, you could limit the names to just 1 instead of many, because this is saying that you can have 0 to many, but you could come in here and say that it's changed the cardinality. You could say that the identifier number is this is saying the NHS number, so that's something that is very specific of where you get that number. You could say that your marital status is of a specific code system, maybe it's an international one. You could say that instead of the photo having 0 to many, you don't even support photos, so it's not gonna, you're not gonna have any. And you could say that you're gonna change something, there's this kind of open area down here in linking that you want to support ethnicity. And so you can add something entirely new to it because you link to something else, you link to a different resource. So the extension definitions, it's, the extensions are really a big part of how you make FHIR work. So they can be very simple or complex, and there's a lot of information about how to do this under that extensions tab out on the FHIR specification. Implementation guides. So some people think that implementation guides and profiles are maybe kind of the same thing, or they're equal, but they're very related. An implementation guide is essentially the grouping of lots of profiles. And so what we do is really think of it in a use case. So implementation guides are often titled in a way that they're similar to what use case are that they're supporting. And so you take your use case and you say, in order to do this type of care or this type of exchange of data, I need these data elements. So I grab the resources, I profile them, and then I bundle them together into an implementation guide so that that is how I meet that use case. So you can both restrict and extend with the APIs, the resources, and what terminologies. Currently, if you go out into the FHIR Foundation site, you can find 169 different FHIR implementation guides. And there are more out there that, again, are with simplifier.net is one of the common sites that they put them. The ones at simplifier.net would not have gone through the HL7 ballot process, but the ones that the FHIR Foundation has. And the only reason I have all these icons over here listed on the right side is that these are areas that are looking at, and they create a lot of implementation guides. They're called the accelerator programs, and they are all have very different clinical focuses. So like Karen is looking a lot at the patient perspective. Codex is looking at cancer. Da Vinci is looking at the payer information. Gravity is about social determinants of health, and Vulcan is about the pharma. And I don't even remember right now what FAST and Helios are doing, but they're out on the accelerator site, so you can see that.
Helios is public health, and FAST is FHIR at scale.
Okay.
So nationwide FHIR exchange.
And these slides will get available to you because there's a ton of links in them, so we'll post them on a Confluent site that you can get them, and these are links that you can find those different places to find those registries. So this is just a slide that talks about what is REST, and we talked about representational state transfer, and it's how you can connect things in real time, and we use the examples of the airlines and others. Like I said, this is not anything new to healthcare. In fact, it's best, and it's great that we're using something that is really best and well known in computer science and in the world, the way we're using in computers in public today. It uses the HTTP. It's very simple to use. It's very common, which the best thing about that is it brings a lot of knowledgeable folks about this technology to the table. In our past, we had a lot of things in our healthcare technologies that are very specific and not very well known to a lot of developers, which then you, and many of you as developers probably know, you get a job in an institution and you have to learn a whole new computer language, you have to learn a whole new database, you have to learn a whole new everything. You thought you went to college and you got all of these great degrees and letters behind your name, and you had to go and learn a whole new thing when you got a job. Welcome to healthcare, right? So maybe I should say we should add to this that we could help the developers burden as well by using FHIR, not just the clinical burden. It's very simple with the interactions. It uses what we call CRUD, the create, read, update, and delete. And there's a lot of tooling and experience out there. And the other thing about it being stateless is that it's better to help us so we can scale things. Because that's the other thing we find in healthcare is we can sometimes create these really great little widgets for a pilot, but it's really hard to take it anywhere outside or bigger. So again, FHIR is freely available. It's free for use. There's no membership required. There's the licensure is on the website, which you can find there. And if you want any more information, there's a million links so you can talk to us. So that is where we are on the deep dive.
You should, if you don't have the script, the 5-page paper
That piece of paper.
handout, which is the cookbook step-by-step instructions for the hands-on part we're going to do in a few minutes when we come back, pick one of those up. The web tool we use works best on a Chrome browser. So we will get started with the hands-on exercise here. There is a paper script which begins with a little bit of an explanation of the tool we're going to use and a very simple patient story. The tool I mentioned a little bit in the introduction. The tool is called Graph Builder 2, gb2.clinfire.com, is a web app developed by Dr. David Hay in New Zealand and maintained by him. And this is not an announcement because it's unofficial, but as we are finalizing an agreement for InterSystems to sponsor his maintenance of that tool going forward. Very excited that that has happened. It's a very important tool in the FHIR community used by many FHIR developers to start developing an app. In other words, the first step is to decide what data is important to your app and what FHIR resources do you need in your app scenario. So you build a logical model with this tool. And the tool has a number of features, not the part we're going to use today, but the larger suite of tools allows you to provide some synthetic data for you, synthetic patients, I shouldn't say data, but synthetic patients with some FHIR resources and such. So it's used by developers to start developing. What you do develop, you can cut and paste JSON out of this tool into an application that you might actually be building. What we're going to use today is sort of an entry-level module called Graph Builder 2. And it allows us to get a visual picture of what we're building and allows us to get down into the look under the hood, as I would say, at how FHIR works and look at the data elements in some of these resources, and very importantly, to understand how resources are connected with one another. So we that's what we'll be doing. That the tool has a human-friendly FHIR editor called FHIR Shorthand built into it now. So if you want to manipulate a FHIR resource, you can use this editor to do so, and we will do a little bit of that. There's a couple of people in the room. If you get stuck on something, you can raise your hand and they will come help. There is no exam, so don't worry about if you missed something. The tool is freely available. If you're really interested, you could take that script home and go back and try it again. The tool's there, freely available. And if you are on the developer side of things, then you may want to actually use it design something, build something. It also now has an implementation guide viewer as part of the tool, so you can start to look at more complicated things. So I created a simple little story of a problem a patient with a problem list, because a problem list is sort of a essential piece of managing patients and demonstrates a lot of the concepts that we need to understand FHIR without being too complex. But those are the same concepts that apply to much more complex use cases. So there's a individual who doesn't have a gender in the story, so you can give them whatever gender you want. They are going to the doctor because they have a tender left elbow. They've had asthma in the past, but it isn't bothering them now, and they have diabetes, and they reveal in the social history when they see this new primary care provider for the first time that they've been using e-cigarettes. So it's a social determinant of health. And social determinants of health are pretty much all observations. So the FHIR observation resource is a very flexible resource that gets used to represent anything that is an observation, whether it's a lab test that a device observed, if you will, or something a clinician observed, or something a patient observed. They're all observations. So that the story is not meant to be particularly clinically profound. It's just a simple demonstration of how FHIR might be used. The other thing that it's in the script, but I'll say it again, this should not be interpreted as how a FHIR app works. The tool is, you might say, tedious in that you are hand manipulating some things that would not be apparent to an app user. So this is not a FHIR app. This is a tool to better understand FHIR or to build something with FHIR. So with that.
All right, so in the handout that you have, the second page, back of the first page, is the narrative that he just mentioned. So if you have any questions and you want to go back to, because we will pull some clinical data out of that, just know.
You're seeing my screen if you hadn't.
Yeah, so how we do this is that he's going to drive and be following along in the Graph Builder tool, and I'm going to be tracking us through the script. So you can go ahead and pay attention to your computer, and I'll be kind of reading it. And if you have a question, you can look at what's written. I'll tell you where we are stepwise every once in a while. And he's going to be showing it on the screens up above, which would also still be on the WebEx if you want to alt-tab between what you're looking at on your screen and what he's doing. So first of all, what we need to do is, Chrome is preferred if you can. Go to gb2.clinfire.com. So in your browser, go to gb2.clinfire.com. And if you want to, on step 1 of the follow along exercise, page 3 is where the caps are if you seem to need to know the caps. gb2.clinfire.com. You do not need to create a login. So the login just allows things to be stored, elsewhere. We need to just store locally, so you don't need to create a login. So it's going to look kind of blank, which is what he's got here. And there's 2 buttons at the top, the library and the download project. And you can click on the library button, which is blue and on the left. And you'll see a drop-down menu come up. Scroll down to the bottom and find the GS 2022 problem list exercise. So you've clicked the library button. You're going to scroll down and find GS 2022 problem list exercise. It's at the very bottom of the list.
And that list loads a little slowly sometimes.
So anybody having trouble? Are we all there? Okay. You're having trouble? So Chrome browser, you got so did you click on library? Is it just slow? Okay, so it's slow. We've had issues today where sometimes it's slower. So kind of follow along a little bit. You might be able to catch up because you have it in writing. All right, so After a little while, you get that problem list. Click on the download project button. So you've clicked on that GS 2022 problem list exercise, then click on download project, the green button at the top. So go ahead and click on the gray letters that say GS 2022 problem list exercise, and you should see a graph in the middle of the screen. So you click on the black letters in the gray, and you see a graph in the middle. And there's 5 tabs above. The graph is usually black, and then you're going to see blue letters, references, content, audit, and JSON links. Those are tabs. So when you scroll down and you look at that graph a little bit, each of the colored box represents a FHIR resource. And if you hover your mouse over a box, you'll see what type of resource it is. And we will share with you, we've told David that the color choices he has on these boxes does not go well on WebEx. It's not a priority of his. So anyway, but if you just hover your mouse over it, you'll see what kind of resource is the base resource. So up at the top of that middle section, click on the References tab. And you're going to see a list of FHIR resources come up kind of over on the left. It says Resource. And then you have a column on the right which displays the references between the resources and the graph. So you can see way over on the left or the right is the linking. And the GB2 app only allows one patient in a scenario. And a scenario is a graph. So we can only put one patient in any one of these graphs. So it will automatically assume on some of these things, if it needs a patient, it's going to go to this patient resource. So that will get automatically linked to you at times. And so that patient that you see is always the subject of the condition and all the encounter resources. So everything we do is going to go around that patient. All right. So now we're going to keep going. I'm on step 9 on page 3 that says click to highlight the asthma condition, that resource on the blue letters, and see details for that resource. That comes up over in the Details View tab on the right panel. And over there on the right panel near the condition, way over on the right, you see a little circle with an eye in it. Click on that eye symbol to open a separate tab to the FHIR specification. So anywhere you see the eye, it's going to take you out to the FHIR spec. So if you're in the midst of working on this and you're wondering what's going on and you want to read the FHIR spec, click on the eye and it will take you out to the FHIR spec. And let's see, to get back, you need to just hit the back arrow.
No.
It's a new tab, isn't it? It created a new tab. So click on your tabs at the top. When you click on the eye, it puts it up into a new tab. Okay. So now we're in step 10. In the right, everybody should be back on Graph Builder 2. You're not looking at the FHIR spec. You've highlighted asthma, so there's a gray line through asthma, and you've got the selected resource information over on the right. So over on that right screen in the panel, click on the resource content. It's the blue, so right under selected resource, there's 3 tabs. The one way over on the right says resource content. Click on that, and you'll see 3 views for the content of this, more tabs. You've got FSH, JSON, and XML. FSH stands for FHIR shorthand, and we call it FISH. So if we say FISH, it's FSH, FHIR shorthand. And then the JSON, the JavaScript object notation, and XML, the extensible markup language, are just 2 of the machine-readable formats that are included in the FHIR spec. FISH, FHIR shorthand, is a human-friendly editor for FHIR resource content. So there's nothing under JSON or XML right now because we haven't filled anything in yet, but we'll be coming back to that. So now have the FSH one highlighted, and then go over to the little pencil in the square. Way over on the right, there's a little tiny icon that looks like a pencil in a square. That's the editor for the FHIR shorthand editor. And you can click on that. And that window will show the current resource condition as a list of all of the included elements that you can work on. You can see the element's cardinality and the element's data type. So click cancel right now because we're going to come back to that. We just wanted you to show what that does. And now once you've canceled out of that, you can click on the content tab in the middle of the screen. So now we're jumping over to the middle where it says content and click on that. And you can return to all the different individual resources that we have so far in this scenario. All right, we just finished step 12. Everybody following along? Awesome. All right, step 13, we're going to add a new resource. So click on that Add a New Resource Instance, which is the green button up on the top right under the InterSystems logo. And we're going to add 3 FHIR resource instances. Find condition.
When you click on that, you see all of the FHIR resources, and you pick which ones you want. The easy way to pick them is to start to type the name of the resource into the enter filter box, or you can, if you're good with the alphabet, find the one you're looking for. Anyway.
We're looking for condition to get started. So click on condition. There's going to be a display box. There's also a filter. You can type it and find it. And in the display box, type tender elbow.
So you're going to download an empty condition resource, and what we're filling in here I think of as sticky notes. We're putting a sticky note on the empty resource so we can remember what we created it for. What we type in here is not data in the resource, it's just our sticky note to remind us what we were going to use that for.
So in the condition display, type tender elbow, and in the text box, put left elbow. Display is tender elbow, and text is left elbow. And when those are typed in, click Save.
Now you see you've added that to the list of resources. The reason for picking tender elbow is to make the point that everything on a problem list is not a diagnosis. Tender elbow is the patient's complaint. It might be listed as the chief complaint for why they came to the clinic or hospital, but it's not truly a diagnosis. It may become a diagnosis when somebody figures out that that's an infected elbow or it's arthritis or something, but at this point, it is not a diagnosis. It's a condition or a health concern, as they're sometimes referred to. But the point is, problem lists are not strictly a list of diagnoses. They are concerns of the patient. So,
all right, we're going to add another new resource. So click on the Add a New Resource Instance button again. And this time we want to find practitioner. And you can use the filter box if you want to help you find it, or you can scroll around and find practitioner. And in the display box, make up a provider name. Donald Duck, Mickey Mouse, your grandfather's name, anything you want. Just create a provider name, and you can save. And then we're going to create another resource. So click the green resource instance button again. And this time we want to add a list resource. And in the display field, we're going to call this the problem list. So again, we're going to the green new resource instance, find list, and call it the problem list. Again, they're kind of sticky notes. It's help. You'll kind of see when we get to it.
You can put something in there.
You can if you want to. I mean, like on the practitioner in his example, he put penny primary and then put PCP down in the text. But
so remember that the list resource, like many resources in FHIR, is very flexible. So it might be a list, might be a problem list, which it is in our case. It might be a list of patients that a practitioner has in the hospital. It might be a medication list. They all amount to using the same resource. Part of the intent of FHIR is to keep it as simple as possible and reuse as much as possible, which is also a common aim of software development, is to reuse stuff and not create a new. So anyway, that's the idea of some of the FHIR resources, is they get used for different things, but they are only one resource. That's how we managed to have about 140 FHIR resources instead of 300 FHIR resources.
So once you've saved those 3 new resources, if you look in the middle of your screen, under the Content tab, you should see those 3 things. You should see in your list, under the Patient Asthma Diabetes Office Visit, Tender Elbow, whoever you called your practitioner, and a problem list. You should have those 3 things. And so now, right above there where it says References, next to Content, click on the References tab. And you can see that the subject of the patient has already been assigned to a few of those things, to the tender elbow and the problem list, but not the practitioner. Practitioners are not automatically assigned in this tool.
So, right, and the other thing is, if you're working with your enterprise system, a practitioner only exists once in your system, so they're not linked to every patient that they see. The patients are instead linked to them.
Okay, so now we're going to start using these resources that we just created. So if you're not already on the Content tab, go ahead and click back on the Content tab and click on the asthma line. And in Details in View over on the right, click on the Details in View tab that's under Selected Resource. And on the lower right, click on the Potential Preferences in this view. Potential Preferences in the view, it's kind of down below. Hover the mouse over the items under Path, and that will give you an explanation of what those things are.
Does it say?
So you can see, like Russ is resting over encounter, and it's telling you what the encounter is a bit. It gives you a little bit more information with the mouse hover. But we're going to click the Add Reference next to Encounter. So if you follow that line of the path encounter and over towards your right, it says Add Reference. Click on Add Reference to associate this condition of asthma with this encounter.
And if this scenario had more than one encounter, you would choose between the encounters, but we've only got one encounter resource, so that one is an automatic.
And the reason you have them is Russ created a few of these before we got here today, so we didn't have to start at the beginning. So those 3 that we just added, he'd already added all that other stuff so that we had that started, a little leapfrog. Okay, so now we've recorded. So next we need to choose who recorded the asthma as a condition. So we go down to the practitioner and Add Reference. And that's going to tie that penny primary, which is what Russ called his, whoever you named your person, your practitioner, to this patient. And now there's an asserter of the patient. So click on the Add Reference next to the asserter of the patient.
So the choices you're given are the patient or the provider, and if the patient had gone to the provider because they were wheezing and having trouble breathing, and the practitioner said, "You have asthma," then they would be the asserter. But in our little story, the patient had asthma 5 years ago, hasn't had trouble, so they're reporting that they used to have asthma. They're the asserter. But the important point about this is that this is metadata. Metadata is data about data. You're capturing who recorded it and who said it was true, who asserted it. And that will go with this condition resource when you've created this instance of it. That will go with this condition resource ever after. So if you send that data to someone, or if they query and get that data, if they query and get the patient's problem list or conditions, they will get all that metadata with it, which is quite a different concept from just getting the list. And so that's one of the ways FHIR really enables the kind of interoperability that's needed, and you carry the metadata with the important data element has all this metadata with it so that it can be queried on that basis. You could query this patient's data to see when all of their conditions were recorded, or what practitioner, and it might be in some other scenario a different practitioner. Important thing is all of that data goes with it, and you don't have to get the patient's record or chart and search for who recorded that or who asserted that or whatever other metadata you're interested in. It becomes part of this FHIR data representation.
So we're just now on step 17, and we're going to click on the graph tab, and that's in the center section, kind of over on the left. Under the view details initial view, there's a graph blue line. It's a tab, graph. Click on that, and you can see all these connections we just created in the graph. You can see the new resources that were added, and you can see the arrows between them. And remember, an arrow indicates a reference.
And the arrows have direction, one direction, and the FHIR is referred to as a directed graph because it connects one resource to another resource in a particular direction. And this is a whole different concept, which I guess is one of the important things to realize today. When you've got a collection of FHIR data, you have a bag of resources. And if you looked at them, you would just see a bag of resources. The computer knows by these references what the relationship of those resources is. But there is not a document there. There is not an actual list there when you store a list, if you will. There's the computer instructions of how to create that list and what the relationships of those resources are. What it means is if you query a FHIR repository for your patient's data, you can query and say, give me all the resources that are connected to this one patient, or you could say, give me all the observation resources or all the cholesterol levels. That's one thing we didn't mention in this morning's overview. You know, HL7 V2, which, as I said, will be around till the apocalypse, I presume, it does not give you the ability to query. It's a messaging standard. You can send data, but you can't query. FHIR can be used as a messaging standard, but it is also inherently queryable through a REST API. So big difference, and one of the powerful things about FHIR, if you will, but you can query for just what you want. You don't have to get the patient's whole record if all you want is their cholesterol levels. So.
Okay, we're going to click on the content tab again in the middle. So we're in the middle of the screen, the line of tabs with most of them are blue letters. Click on content and select the condition asthma. We're going to start looking at how to use the FISH editor, the FSH editor. So you've got the condition asthma selected. Go over on the resource definition tab over on the right side and click on the tree tab if it's not already selected. And under that tree, you can click on any elements and see an explanation of that element, cardinality, data type, and value set. So just try this with code. Find code and click on code. And over there on the right, you can see lots of information about that line item. So click on the next tab that says resource content. You're still in the asthma condition, but go to the resource content, which is the next tab over. And now click on the FISH editor. the editor icon, that pencil in a square. And you're going to see the asthma condition and the elements of that resource are displayed on the left. Find the code line and click on Codable Concept to the right of code. It's about 6 lines down. So click on Codable Concept next to code. And now you're going to get a filter string box, type asthma, ASTHMA, in that filter string box, and then click expand. This is going to bring up SNOMED codes that include asthma. When we click that expand button, the GB2 tool is going out to a FHIR terminology server to find all the possible values for that element and looking up the codes for asthma and their definition. Click on the SNOMED code next to the word asthma, just the plain asthma. We don't know anything about this patient's asthma, so we're just going to pick the basic one.
But before you do that, I'll make the point of to notice how many codes there are for asthma. And this is the reason we have to have a detailed information model for whatever application. If we're creating an application around asthma, for a problem list, maybe we need all of these, but if you're creating an application to treat asthma, you want to create a value set of the codes for asthma that you would want to be able to represent in your app. Otherwise, there are too many choices that too many different people could make a different choice, and there's no interoperability because they really meant the same thing, but there were 2 codes that had similar meaning. So this is an indication of why we have to have value sets to really create interoperability. We have to constrain it to the appropriate model of what we're trying to build an application for, if you will, by picking only the codes we're going to allow. And we would also want to specify the code system in most cases because ICD-10 has a bunch of codes for asthma that are equivalent to some of these codes. So you don't want to allow an app to have either an ICD-10 code or a SNOMED code that means the same thing, because then you don't have interoperability. So, okay.
Yep, we're on page 6, letter G. So we click on the SNOMED code next to the word asthma, just the plain word asthma. And the URL and the other thing is the URL for SNOMED appears at the right as a new line in the fish box. So did you click on that yet? Yep, you did. Okay. So now let's go to clinical status and click on Codable Concept next to clinical status. It's just the second one down. And click expand there to find the value set for the clinical stat. You don't have to put anything in the filter string box here. Now, this is the one thing that I will say from my user perspective is it's a little bit of a mystery sometimes where you want to put something in the filter box and when you want to just hit expand. If you have any concept that it could be a super long list, then try to put your concept in there and expand. If you aren't getting anything, then hit expand. It's probably a small list that you can't guess.
Well, it's also a required value set is the reason it's a short list. You don't want to allow too many different possibilities for clinical status, or once again, there's no interoperability. So the FHIR specification has said you must use one of these 6 codes for clinical status. Clinical status is very important at the same time because it's important to know whether this is something a patient had long ago or is an active condition, if you will, right now. Otherwise, as individuals get older, they would appear to have a lot of conditions because it was everything they had ever had. In this case, we were told in the little story that the patient hasn't had asthma lately for 5 years. So it's inactive, and that's important to capture in the data, if you will.
So yes, today we want to choose either inactive or remission because this patient is reporting they have asthma, but they haven't had it for the last 5 years. So choose something along those lines, click Save, and now you can see that the values you've selected are there in the FHIR transcript on the right. If you click on the JSON tab up on the right panel box, it's going to be empty. But then way over on the right, you see those double arrows kind of above and below each other. Click on those. And that is just a tool that's going out to generate the JSON. So you click the green arrows, it's going to generate the JSON. And now you can see that in that middle box. And this is for this instance of condition that's representing the patient's asthma. At the top, you also see green that says the JSON instance has been created. He took it away. It used to say all good. Looks like he changed it. It's like, well, that's kind of boring. I liked all good. Got to get a little pat on the back. The green bar specifically tells you that it's a valid resource. So we didn't miss anything that was required. We didn't mess it up in any way. If you did something in your FHIR and you were editing it, then if it didn't do it right, it would tell you that.
So that this is literally going to a FHIR server and validating what you've created, that it's allowed according to the FHIR specification. So to pick a silly example, if this was the patient resource and you gave them 2 birth dates, that would not be valid. Now to the computer doesn't know that patients don't have 2 birth dates as long as they're properly formatted dates. But the FHIR specification says patient resource only can have 1 date of birth. So it's validating everything that's in the specification or validating what you've created against the FHIR specification to assure that you haven't created any bad data, if you will. Very important if you're creating an application or if you're receiving data from an application that you start out by confirming, validating that the data is valid and the FHIR specification is set up to enable that. But that's what all those all the machine readable content is about. Nobody has to create that validation capability. It's built in, if you will.
All right, let's push save. If you haven't already, push save in this screen. Okay, now click on the content tab and click on the patient, the I'm a patient. And then on the resource content tab under the selected resources, over on the right, click on the FHIR. If it's not already selected, we need to be on the FSH. And then go into the FSH editor again, the pencil in the square. And now you have a screen that says the FHIR editor, I'm a patient, and the elements are displayed there below it. We're going to give the patient a name. You can use your name or make one up. Go to the human name text, the human name, and give them in the text a full name, a given name. Something, again, this is a label. It's not part of the resource. It's a sticky note label. Sure. And once you've done that, fill these out. You can click Insert. And once you've done that, over next to General Practitioner, click on Reference. So General Practitioner Reference, and add your practitioner. You should see your practitioner there. Select it so that you can add it. And now we're going to give the patient an identifier. So click on the identifier. And you can assign the value box is all that you need to do. You can leave the other ones empty. And you can make it up.
So the system box would be whatever assigning authority, whatever hospital system has assigned this medical record number, then that would stay with the FHIR patient resource so that you could use it for patient matching, because you know that some system has assigned this value, and you're allowed to have more than one identifier. So a patient has a record number in more than one system, you can capture all that in their patient resource. Once again, that's going to go with that patient resource when it gets queried or sent somewhere else, so that you essentially have patient matching capability built into this. Although they could have a different patient resource in another system.
So push insert, and I'm going to let you do gender and birth date. So for this patient, I'm a patient, pick a gender, just click on the code and pick a gender, insert that, and then go back and select birth date and enter a birth date.
And gender in most HL7 standards, it's not about gender identity. It's called administrative gender. You probably run into that. It is, I usually define it as, it's what your DNA says you are. You can't change that. If you did change it, it wouldn't be a good idea, because that, as you probably know, is one of the elements in patient matching, and you would, if you changed an individual's gender in their record, it would create patient matching problems. But anyway, administrative gender is what your DNA says you are. So,
all right, so click insert and do birth date.
So to edit these, let's say you didn't do the limited stuff, you can add it directly, right? Or if you insert it more than one, you can just delete it right on the editor. Because everything here is default is an insert.
Yes.
yeah. So if for some reason you got something that you didn't want, you can delete it out of the editor, and then when you create the JSON, it won't be there, right?
Yeah. Okay, gender and birth date. Did you get a birth date in, Russ, or do we not need you to? Once you've done gender and birth date, then you can click Save and click on the JSON tab on the right panel. You'll need to click on the double circular arrows to get the JSON to update. So save the birth date and go click on JSON. And you should get the all green. Oh, there it is, all good. We got all good. All right, so now go over to the graph button, way back over in the middle on the left again. Click on graph and you can see your new current links. It's building, it's growing. All right, we're gonna build a list. Next thing we're gonna do is build a list. So go to that content in the middle of the screen and click on problem list. And then on problem list, click on the resource content tab over on the right and open your FSH editor symbol. So then find status and click on code. And choose current.
You'll notice that this status and mode data elements are cardinality of 1-to-1, meaning you must have one and you can only have one. And that's why they're in red also.
So we want to make the code for status be current and the code for the mode be working list. So we're going to have a current working problem list. Now, next to entry, click on the backbone element. I'm getting ahead of Russ, sorry. Okay, so now when you're in this editor and you see your problem list, go find entry and find backbone element and click on the backbone element. Then click on the reference next to item.
So a backbone element is anything in a FHIR resource that you can have a repeated set of, in the patient resource, they may have multiple addresses. They may have a previous address and a current address and a work address. Each of those addresses has a street number, street, city, state, zip. So all of that, when you look at the tree view, it looks like a backbone sticking out is how they came to call it a backbone element, but it's something that is a repeat set of data elements like an address. In this case, each item on the list is going to have certain elements in it, so it's a backbone element of a list.
Okay, so click on reference next to the item and choose one of the two conditions, which is the asthma or the diabetes. Select them. Select one. You can only do one at a time. Click insert, and then we repeat that. So go back to the backbone element next to entry and click on reference and go select the second one you haven't done yet and say insert, and then click on save. And in case you haven't found it, on this there's also a little circular arrow right at the top of the, way over on the right next to where you find the fish editor. Click on those double arrows there and we should see that we have two problems added to our problem list. Oops. All right, and then go click on the graph and you're going to see the list resource has the two problems connected to it. Okay, now we're going to look at adding some observations. So we're going to go back to the Add New Resource instance and find observation. So when you get to observation, we are going to do some social determinants of health. And in the text, put e-cigarette user. So display a social determinant of health, or SDOH, and the text e-cigarette user. And then you can save that. Go back to Add New Resource instance and find organization. And when you have organization open, we want display to say Good Health Incorporated, Good Health Inc. And in the text, payer provider. And say save. Now click on the References tab. And the subject for the references have been automatically assigned. But there isn't one for Good Health, the payer provider organization.
Once again, you're only going to have one organization resource in your system for Good Health Inc. So you don't connect it to all the patients or practitioners who are associated with that organization. You connect them to that organization.
All right, now we're going to go through getting some more values into our scenario for some clinical context. We're just starting step 25 on the handout. So go to the Content tab. Under the initial view in the middle, click on the tender elbow condition. And go to Resource Content. Open the editor symbol. We're still in tender elbow. Into the fish editor, go to code, find the codable concept, and in the search term, type tender elbow in the filter string, and say expand. And you can find the SNOMED code, click on that SNOMED code to choose that value. And then go to the body site and do codable concept. And in the search term, put left elbow. And you can expand that. And then choose the SNOMED code for one of those. Choose any one of those. And next to encounter, click on reference and select an encounter. So under encounter reference, select the encounter. And then you can say save.
Once again, you're creating for that condition resource, associating it with the encounter when it was observed or diagnosed, which will always be associated with that condition. You don't have to go look for it later.
All right, save, and then generate the JSON with the circular arrows again. How are we doing? Everybody keeping up okay? No, that corner's having a hard time over there, aren't you? I'm sorry. I don't know if one of you that's done this before can go step over there. You might be able to help them. I think it's because your computers aren't keeping up. All right, we're on step 26. Now we're going to go click on observation resource, the social determinants of health. And click on the resource content tab under selected resource. Open the editor symbol. And on the very first element that is requiring something, which is the first element on here that says something's required? Status. Good job. Click on code. And then pick a reasonable one. And once you've selected it, click insert. All right. Then you go to the next one and click the code is the next one that's required and click on codable concept there. And enter a search string in the filter box of something like what was observed, the observation name. Something like, what would you ask the patient about e-cigarette use? How many do you use? Often? Yeah, frequency. How often?
So the name of the observation is not the result. It's what you were observing, right? The e-cigarette use is what was observed, not what you were observing. So it's essentially the question you ask, do you smoke? And if you put do you smoke or smoker or something like that in the filter string, you'll get a long list of codes with different questions.
Did everybody find something there? Did you get something in there to select?
So you can see the questions include, if you just put smoker, everyday smoker, heavy tobacco smoker, light tobacco smoker, and I know from the codes, looking at the numbers, the type of digits or characters that the codes have, that those are LOINC codes. So LOINC codes are used for labeling laboratory tests, but they're also a whole a collection of LOINC codes that are questions that you would ask in a questionnaire or survey, as they're often called. And in this case, as part of taking the social history, those are LOINC codes for a particular question. And the reason this was included is to make the point that not only do the values have to be standardized and you have to have a set of codes for the value that you're observing, but you have to have a set of codes for the question you're asking, and you have to pick one. Otherwise, there are all these many different ways to ask somebody if they smoke, and if you ask one question in one system and a different question in another system, it is not interoperable. So healthcare is complicated, but the truth is you have to standardize the question as well as the value that is the answer. So, yeah.
Question, so we're looking at smoker, and we can
Right.
see current smoker 3 times with different codes.
Yeah,
Why would there be different codes for that?
because somebody created a different code. And if you go to the LOINC,
The descriptions will tell you. So
if
you'd
you
have
go
to
to the
LOINC.
LOINC and look them up, there probably is a difference in the actual question that you're being asked, so that we don't have all that detail. But the one point about codes is, codes aren't just a word usually, they're a definition of what that word means. So in this case, there would be a definition of what that question exactly says, and there are a lot of ways to ask if you smoke,
Yeah, the description or definition will often tell you
But-
how they've scoped it or something, or define it. I mean, maybe it has something to do with age or something that you just
But it-
never know.
It's very relevant that when we're creating interoperability, we're going to have to standardize the question as well as the possible answers. Otherwise, you get,
It hasn't been the job of the coding systems. LOINC and SNOMED have not taken it upon themselves to entirely limit to like a minimal set. And so if somebody can come to them and argue the need for a code, they will seriously consider it and create it. If they say, yes, we need to do this for this use case. They don't do it willy-nilly. And I mean, I have been part of requests that have been denied. So it's not just a given that you will be able to do that. And many requests that we have made will be redirected, meaning that, well, this is awfully close to this code that already exists. And so could you just use this code as is? And if you can't, and you say, no, I can't because of this, then they may modify just a little bit. So, but they still are not at the, we're only going to create a minimal set. So there's a bit of stuff in there. You can't just pick a code.
but it is important to be aware that SNOMED and LOINC and code systems do allow you to submit new codes, or sometimes they recognize the need. So when the COVID epidemic was first announced or declared by the World Health Organization, within a couple of weeks, both SNOMED and LOINC created codes for COVID-19 because they didn't exist. Who would have thought to make a code for something that didn't exist? But they did, because if you're going to have global interoperability, especially around a pandemic, everybody's got to have a code to use to say. And they also, LOINC created a set of survey codes to ask about travel history early in COVID, when that was thought to be the most important. And then they also created a set of LOINC codes that were about, do you work in a healthcare setting, and answers, standard answers for those. So it is important.
And testing. They had to go in and check everything on testing. They had to add a few things for testing, and they also, whether or not it was new codes, but they had to go into some of their tests and adjust them to include it. Okay, we're on page 10, letter E, and you're going to go to the performer, click on reference, and just pick an appropriate performer for the available choices. So performer, the reference, and you should see the different performers available to you. And we have just talked about what was observed or about the smoking. So you can select probably the primary care person on that one and click save. And we have just a couple more things we're going to go. We're just going to do, let's see, choose a value for this observation. So do we need to, I guess we need to, we have to open that one again. Open SDOH again. I had you close it too soon. So the resource definition, right?
No, we were in this.
Oh, an FSH. Open the FSH. This FSH editor. Sorry. A value for the observation. We need a value using codable concept. So is it down there under value, codable concept? And this is saying there's a SNOMED CT code for e-cigarette user, but there's not a FHIR terminology server that the graph builder uses. And so now you can just enter, we know the code, and so you go to the enter manually button, and I can tell you that the code from SNOMED, you put the SNOMED in there as the system. SNOMED is the system that we're using.
So it's a HTTP web address.
So I guess in the system, put http:// SNOMED.info / SCT. And it's listed in that web address is under number 27 on the page 10. And into the code box, put the numbers 785-889-008. 785-889-008. And then into the text box, say e-cigarette user. Then say insert. Insert, then save. And then the circular arrows to see the JSON generated. And then go over to the graph, way over on the middle section on the left, hit graph. And you can see all the new resources that we entered and all of the connections and references that are represented by the arrows. And that completed our hands-on part of this. And so he says, you can stand up and say, yay, FHIR. But, all right.
Unless you have a tender left
Unless you have a
elbow.
tender left elbow, then you just have to raise your right hand.
Can you do anything with what we just did?
So the JSON.
Could you? Yeah,
Yeah.
You could copy paste the JSON into an application but
What was that particular thing do?
it would record that patient's problem list. But I mean, that's not the purpose of what we're doing. You could, though, with a little more time, quite a bit more time probably, create an application or
And one of the main reasons
the FHIR, yeah, right.
this tool was created for and is used a lot at the HL7 technical connectathons to test. And so it allows them to get the data into servers that then they can run their applications against to test. So that's one of the main reasons this was created as the Graph Builder 2 tool, was for the technical connectathons. But when we were learning and doing that with them, we realized it's a really good way for new people to just get in and kind of touch and feel it and get a little bit more hands-on of how their relationships and how there's certain things that are required and not required and stuff like that. So, but the main tool was for testing.
You know, I see how the model in this case that we've been working with is oriented around the patient. It makes a lot of sense, and the
Right.
connections and relationships. Do you have models that look at the relationships between healthcare professionals? So if you wanted to look at referral patterns among healthcare professionals,
You could
how HCPs changed
yes,
between one another.
you could do that with FHIR. It's not. I don't think that it's evolved to that point that would. But I'm not sure that somebody hasn't built
I think-
that. Most of what's going on with FHIR right now is organizations internally developing something that meets their needs, and I run across things, but there's no way to discover or catalog all of that's going on. But I'm aware there is a lot, and what the other type of thing that I think I get a sense is being used, fire scheduling. It's fairly simple and straightforward, not very clinical, not very exciting, but very functional and useful. And organizations are building scheduling capability with FHIR. You could do supply chain with FHIR, but I don't think anybody's doing it. It's just too.
So I think, I mean, what you're getting at is queries. So there's definitely, when we talk about the different kind of resources and the workflows and the functions and things, there is in FHIR specification the idea of queries and how to use FHIR to write queries. And so to get to the use case, which if I say it right so people can hear it, is that to look across organizations or across providers on how they're providing care. So you want to go and say, I want to look at all the doctors who are prescribing a certain med, or how many doctors are seeing patients with this kind of a diagnosis, and then kind of what's their outcome. A lot of this data today, of course, would be stored in a native database of where they're working. And so you would have to take that native data and pull it to FHIR, which is part of the ONC requirements we're going to be talking about here in a minute, and get it so that it's FHIR kind of enabled data. And then you could write your queries against this FHIR. And the advantage of that is that if you have three different organizations, so like I say in Salt Lake City, if you have Intermountain Healthcare, University of Utah, and the VA, and you want to query across all of them, and you say to all of them, I want to get to your data on these 12 items, and they say, yes, we'll surface that to FHIR, you can write your query against FHIR against all three of them, and then you can pull that together and do that analysis.
But one of the things is that they all those organizations need to agree to use the same FHIR profile or same FHIR implementation guide for this. So I would say it's coming soon to a theater near you, but it's just not really widespread yet, because as I mentioned, a lot of places are building something internally, then they don't have to agree with somebody else to, they build something.
It gets to your point earlier that there can be big variation in the quality of care between healthcare professionals individually, but certainly between systems as well.
Right. And one of the problems that we're going to have to solve is that, as many of you may know, that healthcare hospitals, healthcare organizations, they hire a terminology vendor, and they wind up, independent of FHIR, they have a terminology that they have purchased and maintained by a terminology vendor, and they don't all have the same one. And so we've got to deal with somehow standardizing on that to have really efficient cross-organizational exchange and doing the types of things you're talking about.
So in CDA exchange, we found that providers or clinicians don't maintain the problem list very well. There's nothing about this that's going to change that, right?
Right. Unless, making the problem list more useful and easier to maintain will help. So potentially, and that's not the point of this exercise, but yeah, you could create a FHIR app that is a problem list updater, and that's the type of thing that I think will probably be in the next wave of FHIR apps.
Well, and just even how we do healthcare, because when you think about a problem list and the stewardship of a problem list, our past and our probably current has been very provider specific. And with the push towards getting to more patient engagement, patient involvement, lay caregivers, family, the value of FHIR is that we could start getting apps where we can create tools for more people to see the same list. And we could start managing that list differently so that we can have, views per user, or even I suggest this, or I need to correct this. Now, again, the governance over that is something that we need to figure out. The clinicians don't have an answer yet for how do we, govern across many people on something like a problem list.
But-
Some folks are like, it's my list, don't touch it.
But it's a good start, as I mentioned earlier, that when you create the problems on that problem list using FHIR resources, that is condition resources, then you've got all that metadata of who said, when was it recorded, and we didn't get into the details, but other elements in the condition are when was the onset. When you've got all that data in the problem list, and which is not the case with CDA problem lists, when you've got all that data there and you want to maintain the problem list, makes it a whole lot easier and a whole lot more amenable to creating an app that helps you do that. So yeah, like I say, I think next wave, that's the type of thing that.
Okay, so I'm going to transition this just a little bit and talk a little bit about where we are today with FHIR in the world of use and where we see it's kind of heading. So, so I just want to bring us back to this, where I kind of entered, what is it going to take? And we're really focusing again on this middle part and really the first two data points on the data and the services. And I want to talk a little bit about the compliance pyramid that our team has put together that talks about all the different types of interoperability and compliance to that. So HL7 version 2 is well adopted, and we have it in many places. And as Russ says, I'm not sure it's ever going to go away. It has its purpose. It has its use. The reason we have a lot of the other things is because it doesn't do everything. It wasn't enough. It provides us a lot of structure, but there's no terminology constraints. Does anybody know about the curly braces problem? Where you can have a lot of, everybody defines kind of this little part themselves. And so if you don't have that agreement again from that point-to-point interface, there's no interoperability. FHIR compliance is very helpful. It provides us some structure, and it also provides us some link or SNOMED codes, but they're often very generic, or they're not the same. The Argonauts, which we haven't really talked about them, but you may have heard of. The Argonauts is it's a community of interest is what I call them. They're not a formal organization. I call them a community of interest. But it's where, like-minded folks are coming together to say, we've got to fix some of this, so we're going to create some IG, some implementation guides and things to say, for these simple use cases or so, we're going to say this is how we will define it so that we're compliant to that. It gives you the common resources, some extensions, and some specific linked and SNOMED are defined. But if we want to get to what we call the semantic compliance, so we have true semantic compliance where when we go back and talk about the same meaning of our data, we need to get to a very preferred structure with the standard extensions and very explicitly define what the link and SNOMED codes are, even what the units of magnitude could be, because there's a lot of things that you can still define in the way FHIR is defined.
And even what standard do you smoke questions?
Yes, the standard questions. I mean, there's a lot of things that would help us. So let's just talk just a little bit of where I'm coming from on the standard structure and language. And so a semantic interoperability is where we have the same meaning of our content. And so the data elements are very consistently defined. The syntactic interoperability is where you're using the same language and you have a standardized data exchange. So syntactic interoperability, you can see here with these two examples of the left being HL7 v2. This is, a message here. And on the right is the FHIR represented in JSON. And I can show you what's highlighted in yellow. You've got the name of the person and an identifier, gender, an address. So that content is represented here in HL7, in v2. But in FHIR, it's represented, I have the same content, but it's in a different syntax. So I can do v2 to FHIR, but it's a little bit more complicated because you have to know both languages and you have to be able to know how I'm going to match those together. So if we use the same language, so if we're all using FHIR, it's a little bit easier to meet interoperability because we're using the same syntax. So then, but why isn't that enough? So learning about this is that there's decision making that has to happen. So every time somebody is putting their fingers on this and trying to make a decision on how do I map v2 to FHIR, so somebody's making a decision there. And every time there's a decision point, there's the option or opportunity for just a little bit of drift or a little bit something different to happen, which can make it not be as interoperable. And so, as I mentioned before, V2 had an area where in the syntax there were these curly braces that would require for somebody to make a decision. And if two somebodies make different decisions, you could not match. The same thing happens with FHIR and the way the extensions are made. So you can go into the observation resource and extend it and say, I'm going to put it in as, you know, the vital signs for heart rate or systolic blood pressure or something. There are some decision points in there, just like choosing those LOINC codes, just like looking at how long those LOINC codes are and that there's some multiples and things that happen. And so you've got to look at that clinical definition. It helps, but it's sometimes not even enough just to do that. So we love FHIR. Look at us. We spend a lot of time talking about FHIR. We both teach it. We are also involved in helping with the development and refinement of it. We love the fact that it uses current technology and it brings a lot of very knowledgeable folks to the table who know how to use that technology to help us in healthcare. It's because of these reasons becoming very widely adopted. It's still new. We've got to recognize we're on R4, R5 to be released yet to be known. And so we're not really sure exactly how is it going to look in 20 years from now, 30 years from now. There's a lot of time going into this right now. We don't expect this to be just a flash in the pan. This is a long-term thing. It's still maturing. There's no guarantee at this point that it's going to be backwards compatible all the time. Currently, they're trying on a few things. That's what normative helps us know, is that there's more of a requirement when something is normative to be backwards compatible. If it's not normative, there's no guarantee it will be. And so anybody who's working in there and looking at the spec has to be aware that if they use a resource or something that's not normative, it could break in the future. And so then you have to know about that. So if it does get changed, you have to go fix your application. And the other thing is, we didn't look at it very closely, but if you go to the FHIR spec, there's not very many of them that are normative. I think there's only like 20 out of the 100 and some. And also, the other thing is that the way that it's currently being done with the implementation guides and profiling is that it's kind of causing some duplication and with that some confusion. So it's kind of, people are recognizing and seeing it, so it's just not perfect. That's why it's not quite good enough. So now I want to talk a little bit about what semantic interoperability is and kind of what our problem is. And so let's talk about the item suspected lung cancer. And there are 3 different ways that you could put this as storing it in your database. And some of you probably have seen this done in all of the systems that you work on. So you could come in and say that you're going to have your problem diagnosis is cancer, your body site is lung, and that it is a suspected cancer. Or you could say that my problem diagnosis is suspected cancer and the body site is lung. Or I could say that it's just suspected lung cancer and that's what my diagnosis is, all in one string. Now, many of you know that how that gets stored is 3 different ways. And so what happens is that you can, and this is called pre-coordinated and post-coordinated. So if everything is all in one line, like the suspected lung cancer, that's called pre-coordinated. And then there's this combination of 2, which is when you do suspected cancer, body site is lung. But if you have it very explicitly defined, which we call post-coordinated, it's each line item is stored separately. You don't have to create your user front end to match how you store it. You can create user front ends where it's kind of pre-coordinated for them, but that actually gets stored differently. But most people tend to create the front ends to match how you store it in the database. And so that's kind of, it's like, oh, well, you help the developer by doing it this way, but you help the clinician by doing it that way. We might need to do a little bit of effort in that middle ground so that it can be good kind of for both people. So, but let's just look at this example. So and I know this is hard to see, but what I'm showing you here is that this is a true SNOMED search, and I put lung cancer in. I came back with 33 matches. The top 2 are fairly close to the same. One says lung cancer, the other one says CA, which is a known clinical short term for cancer, hyphen lung cancer. If I would choose one, I get a SNOMED code of this one. If Russ would choose the second one, he would get a SNOMED code of this one. And obviously, if we have 2 different sites and we're both trying to say the same thing, we're not connecting because we have different codes. So let's play that out just a little bit. And here you've got 3 different systems, home care, outpatient, and inpatient. We have a lot of people in that scenario. And they all have the problem list, and they all say suspected lung cancer in some way. You can find in SNOMED a code for every single one of these things. So if we have these things, nobody's going to match to home care because they have their own. And outpatient and inpatient are only going to match on the body site, and we won't know what's going on at that body site because it's not connecting in that way. So one of the things, and I'm going to touch on this, but we are not going into this as a whole other workshop to talk about the concept of clinical element models. And this is where I talk about graphite a little bit, because my team at Intermountain Healthcare that has now been moved to graphite has been doing work around the clinical element models for close to 20 years. And it's based on the history of the legacy systems at Intermountain Healthcare, where we've had a very controlled vocabulary and very controlled data elements in our systems all the way along. And so what we've learned is that we really need to control the main things. You have your name with the value key pairs. But over time, you know that in order to accommodate all the different types of uses, you end up having qualifiers, modifiers, attributions, and then sometimes some links out to some more information. And so this is just a slide kind of touching on the idea of clinical element models. And they're logical representations of these very discrete clinical information, and it's the expression of these very common data elements. You can make them very human readable, and it can also be a computable artifact. What happens is that you have these CEM, or clinical element model libraries, that then they have these defined, and if you're in the FHIR observation resource and you're wanting to profile, instead of going out and searching for, well, let's see, what LOINC code would I like to use today for, what am I looking at, heart rate? Instead, come to where these clinical element models are already defined. And like I said, this is a whole long thing that I can talk about, but the concept of the clinical element libraries are that these are clinically consensus. They're clinically defined, and clinicians have decided that they will agree to say this is a reasonable way to define a heart rate. It's not the only way, but it is a reasonable way, and I'm willing to use this reasonable way for our applications. That would help developers and everyone to be able to say, okay, I can get away from finding my own LOINC codes. I can go to one source, find a reasonable way to define these clinical items, and then match them into the observations or into the resources as we're profiling them. This is kind of verging on, it's kind of current, kind of happening in some places. Graphite is lifting this up to make it more available more broadly. So we have a lot of local representations of where the data is. So the native stores, I call them, are very different. If you go to even within different EHR systems, the different instantiations of where they are implemented, it's not always the same within a vendor. Each site can have differences of how it's been set up. The V2 and FHIR allow for this project-specific terminology binding, but it's very difficult to maintain. So where are we at? It's easy to implement. It's got unprecedented support. And we have other tools and things like Smart on FHIR that makes it really quick to be developed. But like I said, there's no interoperability because the profiling is starting to just go wild. And so just because you create a profile doesn't always mean it's implementable. And it doesn't always mean it's interoperable. So we've got to start. So one thing we said, there's 169 published IGs. I can't tell you how many numbers of profiles in there, and I really can't tell you how many of those profiles are duplicates. Is there a question over here?
Wasn't there some promise effort by the ACA, aka Obamacare, to standardize a lot of this, or was that just something I misheard? I mean, is there any effort by the government?
Yes, I'm good. I got government coming.
So the ACA was actually before FHIR, so there was no.
Yeah, it was, but there are, I think some of the stuff on the ONC slides, let's talk to that a little bit. So I got ahead of myself, and I've already kind of talked about having this, a library of types of things where you could find things. So this is getting into the, imagine a world if, to get where we could really achieve our semantic and plug-and-play interoperability that I talked about on my first presentation, is that we would have in that common area ways that we have known and expected access of the data, and that's where the graphite and the models, the data access and the data definitions, and also I didn't talk a lot about the CIMI, the Clinical Information Modeling Initiative at HL7. They're very closely aligned between that and what graphite's doing, and also how the apps behave. FHIR is really helping us get to how the apps behave so that we know what is that interaction and such that's coming between them. So if we have all of our different native proprietary stores and you want to get to these multitude of different decision support apps, if we could come to the middle and both the apps and the home bases, the native data stores, could have a common understanding, it would really help us with our interoperability and reach this a lot faster. One of the things that has to happen is to get the library set up, and that is just starting to happen, is both with the clinical element models, but also a profiles library. It's just starting to happen. So let's talk a little bit about FHIR in the future, even more from the government point of view. So the 21st Century Cures Act, they had a lot of things in there that are important to this. And this is the timeline that's been out since 2015. And we are currently in this 2021-2024, where we should be doing learning health systems, the person's at the center of the system, continuously improving public health, science. We are a little delayed because of COVID. And so they have adapted some of the timelines for that. This is, I can't remember what day this has been pulled off since this year. So some of these timelines are updated, and I think it's probably still hard to read. It's really hard for me to read, but whoops, I didn't mean to go that fast. Included in this, essentially in the 21st Cures Act, is things that you can call TEFCA, USCDI, the FHIR APIs, and FHIR bulk export. Let's talk about those a little bit more. So this is where they're all spelled out. TEFCA, you guys have heard of that? Maybe? The Trusted Exchange Framework Common Agreement. And then USCDI is getting kind of closer to what I think might have been a follow-on because of the ACA, and that was prior to some of this. The data standardization around the United States core data for interoperability, which is USCDI specification. The standardized application programmer interfaces for patient and population services. And then also calls for the use of the HL7 FHIR for the interoperability. So we'll look at each one of these just a little bit. The TEFCA, and in fact, you mostly only hear it referred to as TEFCA. I don't hardly ever hear anybody talking about it with the full words. It's really a framework around the information exchange. And what it's trying to do is leverage what's in place around some of the HIEs and other things so that we're using the existing infrastructure and organizations and looking at how to get these to be qualified in a way and connecting them, and that you would have a responsible coordinating entity, they call it an RCE, to say that you're qualified, and you're qualified, but you're not qualified yet. So you qualified people kind of can connect and you get some, clout and verification for that. What happened is the Sequoia project is another nonprofit organization, and they have been given the single responsibility at the single RCE designation. There are no other RCEs besides Sequoia project right now. And so they're the ones that are looking at that. And so what happens is that there's these principles. And so if to be qualified and stuff, you're doing certain things around standardization, you're transparent on things, you're coordinating, and you're very non-discriminating. You attest to some of the privacy, security, and safety and access issues, and you're looking at population level data. Those are all simple principles, and there's a lot more information about it, but that's what's included in TEFCA. And the stakeholders are broad, everything from the providers to the technology developers, payers, public health, the health information networks. All of these are different stakeholders, so all of these are part of what's happening with these principles. And these are all the different uses that they expect TEFCA to be used in. And so how it works is that as a participant member, you would agree to be part of this participating agreement and become part of this, a participant. And so then the network of the participants can get qualified through the RCE to become a QHIN, and then eventually the different QHINs can connect to each other because you're all following kind of the same things. So that's what TEFCA is all about. I don't have a lot, there's still Sequoia was just named as the RCE, I think a year and a half ago, 18 months ago. So I think we're just getting the first places qualified. So I can't say exactly how well that's going. It's getting launched. So let's talk just a little bit about USCDI, the data standardization pieces. So the USCDI is where the ONC has come out and said, this is a set of data elements that are important to all of healthcare that we think we should support first and foremost. We are in version 3, is about to be released in July of 2022. When you go to the website, you'll get to see the original version 1, you'll see version 2, and you can see the draft version 3, and then you're going to see a tab that says level 1 and level 2. And level 1 and level 2 are things that have been suggested that people want to have considered for future releases. So they're out there to be seen and reviewed and can be comments usually happen once a year in the winter months, so like January, February, March-ish, and then they publish in the summer months. But I can't say that it's always exactly to that schedule. And what these are is just very standardized sets of data elements that they're getting people to say these are important. The problem with USCDI, some of you, if you look at them, if you have a clinical bent at all, this is like a basket of fruit and vegetables and throw in a steak or two, because these things are not anywhere near the same in what their level of granularity or definition is. And so some of these are a heck of a lot easier to be doing in a standardized way than others. And there's also a lot of things missing. There's a lot of things that people think are a lot more important than what's already on the list. So it's a start, it's an effort, it's happening, and FHIR is paying very close attention to this, and so is the clinical modeling team. So both of those teams are getting this set of data ready to go with those technologies and gluing them together, because this is really important. This is what the ONC is purporting. It's just really difficult for some of these folks because some of them are so poorly defined. So again, low-hanging fruit is getting chosen to be done first. So the standardized application programming, I don't know as much about this, but this is just saying, okay, what are the APIs that we should be doing first? So the ONC has essentially put out what we call the ARCH, and there's 15 specific APIs that they've asked to be aligned to support the USCDI transfer, and this is a list of them. I don't have a lot here as far as how is it going and where are they coming. I don't have the updates, but they exist. And then, of course, it's just using FHIR, which we've spent a lot of time on here today. And R4 specifically is called out in the ONC. So the most recent published full version, draft R5 is drafted, but it is not yet. I don't think it was to be released, but they postponed it, and I don't know that I've heard a new release.
They haven't validated it. It should be Q2 of next year.
Next year.
It will be published.
So R4 is the current. So just a touch and an explanation. If you hear things called about the FHIR accelerators, so FHIR accelerators are where you get a community of interest, and I touched on them before, where these folks are really wrapped around specific use cases in topic areas. And so like for Da Vinci, they've probably published 8 or 9 different use cases and have another dozen in their hopper. And Gravity, I don't know, man, Gravity is a massive project. I don't know, how many of you have heard of the Gravity project? So Gravity is all around social determinants of health, and it is I don't think they expected it to take off like it did. I think it is such a hungry area for anything related to IT that it got audiences of unbelievable scale. They have calls that have 700 people on it because they are just such a hungry audience of needing stuff for social determinants, but they are very methodically going through, in fact, I have a slide on them, all of the things that are related, everything from financial to transportation, to food, to social violence, to smoking. I mean, they've got a world of things that they're looking at, and they're very specifically going through and getting the data elements that are of interest to those areas. And some of them, but not all of them, they're working through the FHIR profiling and balloting implementation guides. Another one we call out is the MedMorph, because it's really important to research and public health. Same thing, that's their focal area. So they're creating their own use cases, their own profiles, their own IGs. There is no oversight or insight yet on how much is happening of any duplication across these accelerators. They all have their own IGs. This is just a nod to the FHIR Connectathons. Has anybody in here ever participated in a FHIR Connectathon? A couple of you? Yeah, they're kind of some interesting events. This is really where a lot of the developers will bring, again, it's very use case specific. There's preparation that happens for 2 to 3 months before the event. Then people meet in a room like this, and they are just heads down around the tables. You can see all these tables, and everybody's, like each one of these tables is a different use case. And you've got different vendors and different clinicians and people, the stakeholders essentially of that use case are gathered around the table, and they are working through sending data back and forth to each other and validating and making sure it makes sense clinically and technically. And so what do we value about those? It's testing everything as much as we can as a pilot type testing. Sometimes the data available is hard to get for some of them, so we do have some synthetic data out of Cynthia that MITRE has created for us to test, but anytime we can get closer to real data is helpful. It's just hard to get. And I could mention it before, the Connectathons is one of the steps to get increased in maturity on the FHIR resources. So there's a book out there that is helpful, that can give you some more information, that was written with Graham Grieve and Tim Benson, and that just call that out. And then this is just looking at, the Cures Act is asking a lot, and those final deadlines are coming up. So we're a little bit behind, but I'm anxious to see what can we pull off. And then the other thing to just know is something else will be coming behind it. I'm sure the ONC and the government will decide what comes next, because they do pay very close attention to this. And I'm figuring that we're going to start hearing stuff. So I think with that, we have finished the presentations. So now we just want to kind of get to kind of the wrap up and conclusion, I believe.
Do you have access to these slides?
I will get them to you.
Yes.
Do you want to do the conclusion? I have a slide I can put up to show you where we will post this stuff.
So while Laura's doing that, thank you for spending the afternoon with us, for motoring through the electrical challenges, and I hope it's been helpful. We've certainly only scratched the surface. I would point out that the FHIR Fundamentals course that HL7 offers is 12 weeks with an expected 10 hours a week of time spent, and it of course gets you to a much more technical competency, but it's still fundamentals. It's not not advanced FHIR. And as the last several years have gone by, FHIR is expanding on so many fronts that it's hard to keep up with everything that's going on. It's remarkable that there is so much progress in so many different areas, but also at the same time, just about impossible to wrap your arms around everything. A lot of people are concerned with the, why don't we have FHIR implemented? What's going on? It's already failed. It's, you hear comments about maturity, and, my response has become, well, why didn't they come out with the iPhone 13 in 2007? Well, because it's the end result of 15 years of people using and feedback and improving, and I think FHIR's the same way. It's we're at the iPhone 5 stage or something, but we know that each model is going to be better and have more functions, and that eventually, as Laura was talking about the backwards compatibility, well, it's sort of the same thing with smartphones. You can use this model for a few more years, but you're going to get to a point that it's no longer functional, that they don't even support it. And so that's sort of the way I see FHIR, evolving, that we and as Laura says about the Connectathons, we test it, we make changes, we come back and improve it, and it is a challenge that the government can only refer to a certain published version. They can't be as nimble as smartphones are. They have to pick one and lay out a program for a few years, but it is making progress. Healthcare is complicated. It's to Dr. Stead's point, the amount of data is expanding exponentially. IBM said at the end of 2016 that 90% of the electronic data at the end of 2016 had been created in the 2 years before that, and the amount of electronic data has doubled every 2 years since then, that's just incredible. But anyway, thanks for coming.
Yes, thank you very much. Appreciate your time.